So in the last video, you guys learned how to calculate molarity and manipulate different types of situations in which you needed to create different types of solutions. In this video, you're going to learn about one last way of measuring concentration, and that's molality. So molality is the number of moles of solute divided by the kilograms of solvent. So it's important that you distinguish between molality and molarity, because molarity is moles of solute, just like molality, but it's divided by liters of solution instead of kilograms of solvent. All right? So let's look at a problem. All right? So it asked me to calculate the molality of a solution containing 17.2 grams of ethylene glycol dissolved in 0.500 kilograms of water. So ethylene glycol is my solute, so I need to take that mass and I need to convert it into moles of solute. So I'm going to put grams on bottom, moles up top. I have 1 mole, and I'm going to find the molar mass of ethylene glycol, which is 62.07. So the moles that I get is 0.277 moles. Then I'm going to divide that by the kilograms of my solvent, which is water. So that's 0.500 kilograms. So the molality I get is 0.554 molal. So instead of molar, you pronounce that little m molal. Okay? So how does this apply and why are we learning this? Well, a really important concept for you to know is that if you add a solid to water, for example, or to any solvent, that's going to change the boiling point. So for water, if you add salt to water, then that's going to cause the freezing point to lower, right? That's why they add salt to roads to prevent it from icing, and that will cause the boiling point to rise. And that's why you add salt to a boiling pot of water right before it boils, because that causes the temperature to be a little bit above 100. So adding salt or any sort of solute to water causes the boiling point to go a little bit above 100 and the freezing point to be a little bit below 0. Okay? So let's look at the formula for determining exactly how much it changes the temperature. So your delta TF, that represents the change in freezing temperature, equals your molality times your Kf, which is going to be a constant, okay? And so the Kf for water is 1.86. So all you need to do for this problem, for A, it asks you to calculate the molality, because that's the m in that equation. So I'm going to do that. When I read this, it tells me I have 65 grams of glucose dissolved in 1.50 kilograms of water. So I'm going to take my solute, I've got to get it into moles of solute over kilograms of solvent. I'm going to take my 65 grams of solute, I'm going to put grams on bottom, moles up top. I'm going to use the molar mass to get myself into moles of glucose, and that gives me 0.361 moles. I'm going to divide that by my kilograms of solvent, which is 1.50, so the molality that I get is 0.241 molal. Then to find my new freezing point after I've added glucose to water, is I need to say, okay, my delta TF is going to equal 0.241, which is my molality, that's my m, times my Kf, which is 1.86. So my delta TF is going to be 0.447 degrees Celsius. What that means is that is how much sugar lowers the freezing point of water. So if the freezing point of water is 0, that means the new freezing point of water is going to be negative 0.447 degrees Celsius. Let's look at this, but now for boiling. Okay, so again, same formula, except now it's delta TB and your KB value, which is going to be a different value than your KF value. So I first need to calculate the molality of the salt in that solution. Okay, so again, I've got my formula for molality. I'm going to take 50 grams of salt, and I'm going to figure out how many moles of that is. So divide by the molar mass. Okay, I get 0.856 moles. I'm going to divide by 1 kilogram of water, and so I get about 0.9 molal for the molality. So to find my boiling point, what you need to do is you need to take the molality, which is 0.9, and you need to multiply it by your Kb, which is 0.512. Now, this isn't 100% correct. There's one thing that we need to consider, and that's that NaCl actually is going to dissociate into Na and Cl when it's in solution. That is something that I'm going to ignore for these problems because it is beyond the scope of this class. Technically, you should take your delta TB and multiply it by 2. I acknowledge that, but for the purpose of this class, we are not going to be concerned about whether or not your solute dissolves or not. We're going to ignore that for right now. Okay? So with that in mind, with that ignored, we're going to say, all right, so my delta TB is 0.5 degrees Celsius, which means that by adding that salt, it's going to raise the temperature, the boiling point of water, by 0.5 degrees Celsius, which means that the new boiling point of water is going to be 100.5 degrees Celsius.